Hello friends, today's lesson is about mole calculations in elements. Mole calculations in elements. The key words in the topic are elements and mole. What is an element? A substance is considered to be an element if that substance cannot be split into other substances by any known chemical process. Examples of elements are copper, iron, silver, carbon, hydrogen, oxygen, nitrogen. You cannot divide copper into other substances. Neither can you divide iron, silver, carbon, or nitrogen into other substances. Now, the next keyword is mole. What is mole? Mole is a measure of a substance that contains 6.022 times 10 raised to power 23 particles. And the particles can be atoms, molecules, or ions. In order to understand what mole is and how to work with it, it may be necessary to recall some numbers of items that have been given special names. Dozen is 12, score is 20, gross is 144. In that sense, can we say that mole is 6.022 times 10 raised to power 23? This number, when written out in full, is 602 billion trillion. You can easily count 12 apples, 20 apples, 144 apples, but you cannot easily count 602 billion trillion apples. Now, this value, 6.022 times 10 raised to power 23, is called Avogadro constant. It is called Avogadro constant, and it is used when working with particles. Now, let us use dozen as an example to work with, and then connect thereafter to how to work with mole. A seller of apples in the supermarket can find the mass of 12 apples. If the mass of 12 apples is 800 grams, that means that 1 dozen apples is 800 grams of those apples. So there's a relationship between the mass of apples and the dozens. And that relationship is given by this formula. We say that dozen is equal to given mass of apples divided by mass of 1 dozen of the apples. If the given mass of the apples is 800 grams, and then the mass of 1 dozen of the apples is 800 grams, then 800 divided by 800 will give you 1 dozen. In the same vein, if the given mass of the apples is 400 grams, and the mass of 1 dozen of the apples is 800 grams, then doing the calculation, you have 0.5 dozen. Now, for moles, you don't use mole for those items like apples. Rather, use moles for particles. But then this number is not easily counted, the Avogadro constant. But the work has already been done in the periodic table. In the periodic table of elements, each element has its relative atomic mass. The relative atomic mass of an element represents 1 mole of that element in grams. meaning that that particular mass contains 6.022 times 10 raised to power 23 atoms of that element. Now, just as we did for dozen, the formula, to establish the relationship between mole and any given mass is given here. Mole in element is equal to given mass of the element divided by the relative atomic mass of that element. I have said earlier that the relative atomic mass represents mass of 1 mole of the element, which contains 6.022 times 10 raised to power 23 atoms of the elements. Now let us solve this problem. How many moles are there in 80 grams of calcium? The given mass is 80 grams. And the mass of 1 mole of the element, which is the relative atomic mass as found in the periodic table, but in grams. So 80 divided by 40 will give you 2 moles. In the next lesson, we are going to look into mole calculations in compounds. But before then, I would like you to like, share, and subscribe. It is important for you to subscribe so that you get notification as soon as the next video is posted. Thank you very much and have a nice day.